So here is the first page of the No Brain Too Small circular motion questions. I'll start off with question 1, which is about the electron rocket that was developed by Rocket Lab in New Zealand. So there's a whole lot of data given to us here, which I've summarised in my diagram here. Remember, it's a good idea to draw diagrams. They don't have to be as colourful as this one, but it's a good way to summarise all the information in a visual way, which makes it a bit easier to conceptualise what the question's asking. So for this first question, it's just asking to show the force due to gravity on the satellite, to show that it's this value here. So remember, with show questions, you don't use the value that you're trying to show in your answer. You're trying to get to that value. So for this, we just need to use Newton's equation for gravity, which is here. The universal gravitational constant will be given to you. Sorry about all the cars, it's a lot busier now. Here, it doesn't matter which order you put these masses in. I'm going to use the mass of the Earth here, and then the mass of the satellite. For this question, the radius is a little bit tricky because the radius is given, the radius of the Earth is given, and then the height of the orbit is given. So you need to add these two values together to get the total radius, because the radius is measured from the centre of mass of the Earth. Now, technically that would be the centre of mass of the system, but we're making a pretty safe assumption here that the mass of the Earth is much, much greater than the mass of the satellite. M Earth is much, much greater than M satellite, is the assumption that we're making, which means the centre of mass of the system is at the centre of mass of the Earth. Cool, and then we can sub all these values in here, and we come out with 1,265.5 newtons, which is equal to 1,270 newtons to 3 significant figures, which is the answer that we're trying to get to. Okay, and then for B, the next thing we need to do here is the rocket and satellite and any space debris at the same altitude in stable circular orbits will all travel at the same speed. So that's regardless of their mass. Show that this is always true by deriving the formula for orbital velocity shown, and use this to determine the orbital velocity of the satellite. Now this problem here and the answer to this problem is going to be used a lot in the rest of these questions, so it's a good idea that you know how to do this. You do this by equating these two equations. Okay, so the satellite is in circular motion, so that means there's a force towards the centre of the circle in the orbit, and that force is provided by the force of gravity. Because this is in space, we need to use Newton's equation, we can't just use mg. Okay, so we're going to equate these two together. So mv squared over r is what the centripetal force is equal to, and the force of gravity is Newton's equation squared. Now this mass over here is the mass of the satellite, and again this assumption comes into play, so I'm just going to call this M2 for the mass of the satellite, so that mass cancels out with that mass there. Okay, so this equation now is v squared over r equals g m1. Sometimes this is shown as a capital M, sometimes this is shown as a capital M because it's a much greater mass, divided by r squared. Now there's some more simplifying we can do here. This r cancels out with this squared. Great, then I'm going to come up here and continue simplifying this equation. So we are trying to find the velocity, so I'm going to take this square to the other side, make it square root, and we get g m over r. So that's the first part of the answer. That's the equation that we need to derive, and you'll see in their equation they've got a capital M here. Right, and now we just substitute in some values to get the orbital velocity of the satellite. I was a bit more organised this time and did the calculations before making the video, but for some reason I didn't complete this calculation over radius squared, which again is this total value here. Just getting a bit lazy there. Cool. And then I will substitute all of that into my calculator and get the answer. 7.61 times 10 to the 3 meters per second. Cool, that's the first question. On to the next one.